Please refer to slide number 38.
38. Yes.
Yes, sir. Here on one junction which has zero velocity on the left hand side, sir. On the left hand side.
Yes. Yeah.
So both the arrowhead on one junction. Is it okay?
Yeah. Yeah, it's not a problem because what this indicates, what it indicates is actually an action reaction. So here you have an effort, whatever effort is here, it is opposite effort over here. What it is telling you is that this foundation, this support is actually providing the opposite effort. So here if this was effort E, this will become minus E. Okay, flows are zeros. So the system is static here. Okay, so actually you find it's a action reaction representation. Is it
Okay, sir.
clear?
Okay, sir. Thank you, sir.
Yeah, yeah. Any other question? Okay,
सर
in that case, yes. Anybody?
इसमें हाँ सर इसमें वो नोड सर कैसे डिसाइड करते हैं सर इसमें से डाउट हो रही है बहुत ज्यादा
नोड क्या?
नोड सर जीरो सर जीरो और वन को सर डिसाइड कैसे करते हैं ये नहीं समझ में आ रहा सर
See, I told you that a one junction is used to model flow. Okay, so all the bonds connected to a one junction will have the same flow. So here, when you're modeling the flow associated with this I element over here, so you place a one junction, connect this I element to it. Okay, because you know that this mass is moving with the same flow. Okay, between these two one junctions, you have to take a relative motion. So you have a zero junction here. That's how, so based on kinematics, this has been done. This is what we call as a flow mapping method. It's very convenient for mechanical systems. Okay?
यस
Yes, Abhinav? As
सर
we
यस
do more
सर
problems,
सर 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 एक छोटी सी डाउट और है सर जैसे वो डैम्पिंग मतलब सर डैम्पर और जो स्प्रिंग है उसके लिए सर उसे जीरो पर से क्यों लिया है सर और वहां पे सर
over here,
मास को डायरेक्ट वन से ले लिया
yeah, you see this mass is having the velocity v. Okay? Over here, what is happening? This C and this spring and this damper have the same relative velocity across these two ends. So you have the velocity of this end over here represented by this source. You have the velocity of this end over here given by this one junction, which is representing V2. Okay, velocity at this. Now you take the relative motion between these two. How do you take relative? You require a zero junction, you require a flow summing junction. So this flow is equal to this flow minus this flow. Okay.
यस सर यस सर
So that is how this zero comes into picture. But this flow is common to both of them. You see, the flow across this spring damper combination is the same. So it's made common through this one junction and this C and R element are connected to it. Is it clear?
यस सर
Over here, you have the flow across this C element. It's the relative motion across these two points. So here you have to take the relative motion across this. That's again given using the zero junction. Okay. And then you can simplify it. You can say this one junction is redundant. So this zero junction is sitting on this zero junction. And so you can simplify it like this. Okay. Okay, Abhinav?
सर एक हाँ सर 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 एक बार पिछले वाले स्लाइड पे जाइएगा सर
हाँ
हाँ सर इसमें सर जो स्प्रिंग वाला जो सिस्टम है सर जो K1 है उसमें उसे सर जीरो पे क्यों लिया सर बस एक लास्ट सर
over here over
यस सर
here
यस सर
yeah because
यस सर
you see there is a there is a relative motion across this spring. So you take the relative motion. How do you take the relative motion? This motion across the spring is V2 minus V. V2 minus V. Okay.
Yes, sir.
So we took the relative motion across the spring. But you see what is happening? The spring is determining the effort, and this effort is common in all these bonds. The effort is decided by the spring. If it is a strong spring, it will produce more effort for the same displacement. And this effort is acting on this mass, okay, and also acting on the other side, also acting on this side. Okay, is it clear?
Yes. Yes, sir. Yes, sir. Thank you, sir.
Any other question?